Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, or good evening. At this moment, I will explain the material of operational amplifier, or we can call it as op-amp. The first one is basic theory of op-amp. Op-amp is an active electronic component that can amplify input signal with a high gain. Op-amp itself is a component consisting of many resistors, diodes, and transistors that are packed in an IC or integrated circuit. In Electronics Laboratory Telkom University, we usually use LM741 op-amp and LM358 op-amp as a type of op-amp. As we can see here, this is the LM741 pin configuration. The first pin and fifth pin is for 0-volt setting. The second pin is for inverting input. The third pin is for non-inverting input. The fourth pin is for ground or negative voltage. The sixth pin is for output terminal. The seventh pin is for positive voltage. And the eighth pin is for NC or not connected. And then, as you can see here, this is the LM358 pin configuration. The first pin and seventh pin is for output terminal. The second pin and sixth pin is for inverting input. The third pin and fifth pin is for non-inverting input. The fourth pin is for ground or negative voltage. The eighth pin is for positive voltage. Here are some of the characteristics of operational amplifier. The number one is voltage gain in open loop is very high. Number two, output offset voltage is very low. Number three, input resistance is very high. Number four, output resistance is very low. Number five, bandwidth is very large. Number six, time response equals to 0. Number 7, characteristics do not change to temperature. This is the definition of the first characteristics of operational amplifier, which is voltage gain in open loop is very high. Open loop voltage gain is the differential gain of the op-amp where no feedback is applied. Negative sign indicates the difference in phase between output or VO and input voltage or VID. Output voltage is much greater than the input voltage. Second, output offset voltage is very low. Output offset voltage is the value of the output voltage from op-amp compared to ground when VID equals to 0. Op-amp that can achieve output offset voltage or VOO equals to 0 is called an op-amp with ideal CMR or common mode rejection. In practical terms, due to imbalance and unevenness in the differential amplifier, VOO is usually a little over 0 volt. Moreover, if no feedback is used, the value of VOO will become large enough to saturate. To overcome such predicament, it is necessary to apply voltage correction to the op-amp so that when VID equals to 0, VO also equals to 0. Third, input resistance is very high. Input resistance or RI from op-amp is the amount of resistance between the two input of the op-amp. In practical terms, the value of op-amp input resistance is 5K until 20 mega, depending on the type. That value is usually measured on the non-feedback condition. If negative feedback is applied to op-amp, then the RI will increase. The greater the RI, the better the amplifier can amplify a signal with a very small amplitude. With a large RI, then the input signal source is not very large. Fourth, output resistance is very low. Output resistance, or RO, from op-amp is the amount of internal resistance that occurs when op-amp works as a signal generator. When this happens, all output voltage will appear at the output load, or RL. In practical terms, the value of output resistance is between a few ohm and hundreds of ohm in the non-feedback state. When feedback is applied, the value of output resistance will decrease until it approaches ideal condition. Fifth, bandwidth is very large, or BW equals to infinity. Bandwidth of the op-amp is the width of a certain frequency where the output voltage does not fall more than 0.707 from the maximum voltage value when the input amplitude is constant. Sixth, response time equals to 0 seconds. Response time of the op-amp is the time that it takes for the output to change after the input change. The output must change immediately when the input changes. In practice, the response time is indeed quite fast but not instantaneous, usually in a few microseconds, also known as the slew rate. These changes are generally accompanied by overshoot, which are spikes that exceed steady-state conditions. But in ordinary applications, this can be ignored. Seventh, characteristics do not change with temperature. A semiconductor material will change its characteristics if there is a change in temperature. In practice, the characteristics of an op-amp generally change slightly, although in ordinary applications these changes are negligible. The ideal condition is only a theoretical condition that cannot be achieved in practical conditions. A good op-amp must have characteristics close to ideal conditions. The next one is operational amplifier operation mode. The first one is inverting op-amp. Inverting amplifier is the most basic operational amplifier circuit, using negative feedback to get a closed loop voltage. The input is a virtual ground because it is a short circuit for the voltage but open circuit for the current. This is the formula for the circuit above. Second, non-inverting amplifier. As the name suggested, this amplifier has an input that must go through the non-inverting input. Thus, the output voltage of the circuit will be in phase with the input voltage. To analyze a non-inverting op-amp circuit, we are using the same method as to analyze inverting op-amp circuits. This is the formula for the circuit above. For the next one is operational amplifier applications. The first one is adder. The function of the adder circuit is to produce one output from several inputs. The formula for adder circuit is as follows. The second one is buffer or unity follower. Op-amp buffer circuit is the op-amp circuit that have straightening value equals to 1 and could be enabled as buffer or conditioner on the output signal. The formula for buffer circuit is as follows. Third, subtractor amplifier. The function of subtractor amplifier circuit is to produce an output from the difference of two inputs. The formula for subtractor circuit is as follows. Fourth, differentiator amplifier. The function of differentiator circuit is to straighten the result differentiation signal input that given. Example, if the input signal form is sine wave, then the output signal will form cosine wave. The formula for differentiator circuit is as follows. Fifth, integrator amplifier. The function of integrator circuit is to straighten the result integration signal input that given. Example, if input signal form is sine wave, then the output signal will form negative cosine wave. The formula for integrator circuit is as follows. That's all for the material of the operational amplifier, and thank you for your attention.